Machine learning is a fascinating and rapidly evolving field that plays a critical role in various industries today. At its core, machine learning is a subset of artificial intelligence that focuses on building systems that can learn from and make decisions based on data. By offering algorithms the ability to identify patterns, machine learning enables computers to improve their performance over time without being explicitly programmed for every specific task. One of the fundamental principles of machine learning is the concept of training and testing datasets. When developing a machine learning model, data scientists typically split their data into two parts: a training set and a testing set. The training set is used to train the model, enabling it to learn the underlying patterns within the data. After the model has been trained, the testing set is used to evaluate its performance. This approach ensures that the model can generalize well to new, unseen data, which is crucial for its effectiveness in real-world applications. Another important principle is supervised versus unsupervised learning. In supervised learning, the model is trained on a labeled dataset, where each training example is paired with an output label. This allows the model to learn the relationship between the input features and the desired outcome, making it suitable for tasks like classification and regression. On the other hand, unsupervised learning deals with unlabeled data, seeking to find hidden patterns or groupings within the data. Clustering algorithms and dimensionality reduction techniques are common examples of unsupervised learning. Feature selection is another key aspect of creating effective machine learning models. Features are the individual measurable properties or characteristics of the data used for training. Choosing the right features can significantly influence the performance of the model. Feature selection techniques help identify the most relevant features while eliminating redundant or irrelevant data. This process not only enhances the model's accuracy but also improves computational efficiency, making it easier to train and deploy. Lastly, evaluation metrics play a vital role in assessing the performance of machine learning models. Different tasks require different metrics to measure success accurately. For instance, accuracy, precision, recall, and F1 score are commonly used in classification tasks, while mean absolute error and root mean squared error are more applicable for regression problems. Understanding the right evaluation metric is essential for fine-tuning the model and ensuring it meets the desired objectives. In conclusion, the principles of machine learning encompass a range of concepts that are fundamental to building effective models. By understanding the roles of training and testing data, the differences between supervised and unsupervised learning, the importance of feature selection, and the use of appropriate evaluation metrics, you can harness the power of machine learning to solve complex problems and drive innovation across various sectors. Whether you are a seasoned data scientist or just starting your journey in this exciting field, these principles will guide you toward creating impactful machine learning applications.